Now we'll summarize every type of area you could be given in inverse normal curve problems or backwards normal curve problems, and how to find these areas using the tables and using your calculator. The first type of area you could be given in backwards normal curve problems is a piece of area between the mean and some positive or negative z-score. When you're given a piece of area between the mean and another value, simply look up the area on the table and get the needed z-score. Then convert the z-score back to a value relevant to the problem if it's necessary. You would use your drawing to determine if you need to take the negative or positive z-score. Obviously over here, your z is positive, and here you would have a negative z. This just depends on whether it falls above the mean or below the mean. If you are solving this type of problem on the calculator, you'll either need to add 0.5 to the area to get the amount to the left, or you need to subtract 0.5 from the area, right? So this would be 0.5 minus our area. If this is the area here, then you would put this amount into your calculator as the area to the left, and also input whatever the mean and standard deviation are. The next type of area you could be given is a middle piece of area like this. If you're given a middle section of area, divide the given area in half and look for it on the z-table. So if this whole thing is equal to a over here, each half is a divided by 2. So you would look for this value on the table, and then you need to remember that you have a positive z-score and you also have a negative z-score. If you're dealing with an application problem, you're going to have to convert your z-scores back to whatever the relevant values are. On the calculator, you have to break the middle area up into 2 halves and treat it like 2 different versions of the last type of problem we saw, where you have this area between the mean and whatever the score is, and then you have this other piece of area over here between the mean and whatever the negative z is. So on the calculator, it becomes 2 problems like this, where this is what you would have for your upper half. You have a over 2 here, and then 0.5. And then for the other one, this guy is 0.5 minus a over 2. So those are the 2 ways you'd find the area to the left. The next type of area you could be given is either an upper tail end or a lower tail end. So this is if they tell you have an upper small percent or a lower small percent. So here what you would do is subtract the given area from 0.5 and look for that value on the z-table. So you can only look up pieces of area like this on the z-table. And this piece, if this is our area A, this piece is going to be 0.5 minus a. Same thing over here. If this piece is a, the piece that you actually can look up on the table is 0.5 minus a. And then you would need to use your drawing to determine, once you find what the z-score is after you look up this area, if it needs to be negative or positive. Like obviously over here it would be positive z, and over here we would be using a negative z. On the calculator, if you're given a lower tail end, well, you already have the area to the left, so you just put this area into the calculator. If you're given an upper tail and you need to find the area to the left, you would just subtract that area from 1. So that would just be 1 minus a. To get this piece, if this piece is a, everything over here is 1 minus a. Now the last type of area you can be given is an area that includes everything above a value below the mean, so everything above a negative z-score or everything below a positive z-score. You'd subtract 0.5 from the area and find that value on the table. So we would need to look up this piece over here, right? But we know our a is going to be bigger than 0.5, so this piece here is going to be equal to a minus 0.5. Because this half of the curve is 0.5. If we look at this one, again, we would need to look up this piece on the table. This piece is 0.5, so what's in here is going to be a minus 0.5. Now on the calculator, the area below a value above the mean is already the area to the left. So something like this, you already have the area to the left, you would just put that area in the calculator. And then to find the area to the left when given the area above a value below the mean, you would subtract the given area from 1. So if you needed to find this unshaded area over here in order to solve this type on the calculator, this is just going to be 1 minus a.